You're doing well. My name is Ramtin with the student ID 1014192226. I'm going to quickly go over assignment 3 to explain in brief how this assignment is done. I imported, it was already coded. We imported the required libraries. We got a content basically from the mentioned URL. And then we're trying to store this image into this variable, and in here by using matplotlib library we can visualize this image. Now we can play around with different features that it has with different values in the target column to visualize different colors. This print statement shows that it has 140 rows, 359 columns, and 3 different values in the target column. If we use one of those values only, which means we're extracting the other 2 values, we're getting a less colorful image because we're excluding the two different values in the target column. This image, black and white, shows again, it proves that there are 140 rows, 359 columns. Then we are using padding. We are basically adding 2 rows and 2 columns, which they're neutral in the beginning and at the bottom of our basically matrix, I would say. And then this kernel is 3 by 3. Out of these 9 values, only one of them has effect. The other ones try to stay neutral. 0 is multiplied by any pixel, becomes 0. That's why I'm mentioning that it's neutral. And now we are outputting our new output array. Then we're defining this function, which is basically saying make sure that all the values that you have is between 0 to 255, so we can basically make sure there's no invalid value, because those are the RGB values that determines different colors, and we don't want any value out of that range. Creating a function to get an image parameter, our kernel that we will specify, and therefore we can do some mathematic approach on those two. So this kernel over here is for detecting horizontal lines. And the reason for that is because each row, they have the same value, so they can have the same impact on our array, on our original array that will be multiplied by this kernel. And when we visualize that, we can see that these horizontal lines are more detected because we are using that kind of kernel. You can see any line that has kind of horizontal direction, they can be visualized easier, and they're detected. They're more eye-catching basically. This is a 40-degree diagonal. You can see 2, 2, 2 in a 45-degree diagonal, and therefore we can see diagonal lines now more than the other lines. Compared to the top, the image picture at the top, this one has ignored all the horizontal lines and it's more towards 2 diagonal lines in 45 degrees. This one is all the way around. Instead of 45 degree, we are putting 2, 2, 2 in 135 degree in this kernel. And therefore there are some lines that are more towards from actually from like bottom right to top left. Those are more visualized. This kind of kernel is good for edges. You can see the edges are specified, like these are 0 but the edges are 1 1 or -1 and -1. Therefore when it's multiplied by our in picture, um, every edge is more basically eye-catching. Then this kernel, which has a -4 in the middle, it is trying to ignore all the edges and goes more toward the actual lines. And the more we increase this middle number, the more we can detect these white lines. It will become more and more detectable and obvious. Now we're going to part 2, loading a data set, putting it in train image, train label, and test. So these train label and test labels are ensured to be converted to basically categorical, so it can be more understandable for our models. Because basically what happens is when it's just writing, our model will not understand it. It expects number to be able to do the mathematical operations, and that's why we have to do that. Then we are putting a kernel keras sequential, which is using different convolutional layers and max pooling, and then we're flattening our array to be um, mathematically possible for our model to do operations on. And then we are using a different amount of neurons in our deep neural network, 128 for the first one and 10 for the second one, to get some output. By using Adam Optimizer, we're compiling our model, and by seeing a summary, we can visualize different layers. The first one is convolutional layer, max pooling layer. All these are used on our model. And now we can train that model. 50 epochs, 50 times it goes through our whole database, our whole table to do the training. By using different batch sizes, 512 will be used in each operation. And then in each epoch, we can see accuracy is increasing and increasing and increasing, because our model is being trained more and more and more. So we can see in the beginning, our model is doing fine, not in terms of accuracy, but at least it's not. We know that it is not overfitting. But when it goes to lower, we see that and we can feel that it is overfitting, because the accuracy in the training is high, but when it goes to testing, it becomes very low. And by visualizing the plot, we can see that the more we're training it, the accuracy for training is fine, but not for the testing necessarily. Which means that it is just memorizing these values in the training. Well, yeah, it did show the overfitting in the epoch number after 30. After 30 times training the model, it tend to memorize some values in the training data. The layers, we saw the summary, so that shows all the details of the layers. So different layers, basically saying convolutional layers is where we want to detect some edges, textures, images, like e- different features of the image. We can use convolutional layers to be able to detect those, and so on. You can see the explanation that they have put over there. So over here we tended to put two more layers. By adding more layers, there is a higher risk that we get overfitting. We like overfit our model because we are training it more and more. And after this operation is done, we can prove that. And we can also prove that by this plot over here. I'm not gonna rerun this because it takes time. Um, I mean, I have to go through this anyways. So you can see the training is very high. The accuracy in the training is very high, but not for the validation, which is there is no point because it is memorizing. So we can get valid data from unseen data. Valid answer. What we did over here was dropping, like by 50% dropping, then we can, it's one of the ways that we can solve the overfitting because we're dropping very random neurons and making sure that these neurons are not always there and therefore our model is not memorizing. So it has to figure out what's going on. It cannot count on those basically neurons always. And when we rerun the training on our model, we can see it has increased the accuracy on the tested. It's increasing by a bit. At least the difference is a little bit less, which shows it is kind of helping in our overfitting. And you can see the previous one was way lower, but this one has become upper in terms of accuracy in the testing. So thank you very much for your attention. Hope you have a great day.